Foodlogical. Good afternoon. You probably feel a little bit tired, so I will start with a joke. A fish walks into a bar. The bartender asks, "What can I get you?" The fish says, "Water, water." But why start with such a lame joke like that? Well, we'll get into that. For now, I want to talk about sustainable inland agriculture. The world has a problem. The population is growing, and so is the demand for food. Though the resources on Earth are not growing in the same way. So we need to be more effective when producing food. One place where we see a problem is in the fishing industry. Already, we are not producing in a completely sustainable way, and there's a loss of biodiversity. Traditionally, fishing has been going out on the sea, taking a fishing rod, and trying to capture a fish. That is the red line, that is the production using this conventional method. The blue line, agriculture, is comparable to agriculture and producing livestock. You catch fish in tanks or cages, normally at sea, because then it's easier to keep them, feed them, harvest them. Though there are problems with this sea-based agriculture. First of all, it is exposed to parasites and diseases of the oceans. Wildlife can come in close contact with these fish and it can spread. There's a loss of 20% of the fish production. Excess feed and manure from the fish is wasted into nature. And lastly, we cannot control the environment where the fish are living, so we cannot optimize the growing process of the fish. With our solution, we will be able to do this. We move the aquaculture from ocean to land, create tanks on land with the fish. This isolates the fish from parasites. It enables us to capture this manure and excess feed and use for energy production. And lastly, we can monitor and control the environment in which the fish live.
We want to offer you a complete, modular, efficient solution. We draw the inspiration from the passive houses. We want our solution to be as energy preserving as possible. We're designing the water flow, we're designing the potential farming of energy. With the water flow, we place it underneath the tanks, so we want to utilize the pressure of water to minimize the energy needed for the pumps. What more we add to that flow is the waste removal. The traditional waste removal, we want to connect it to our next module, which would be the biomass digester. In a fully optimized system, we would be able to retrieve three things out of it. First, the CO2-based coolants that can be used in other industries, fertilizer, and of course, what is the most exciting, the biogas. And the biogas we can use not only to power our facility, we can as well then outsource it and sell it back to the grid. All of that would work under the supervision of IoT systems. We will have 12 sensors spread across the system and the one control unit. 5 main features: tank monitoring, easy feeding, smart energy, on-time services, analytics, forecast, and machine learning for the predictions. We have also a demo for the potential web application where we can track the room, the tank, the filters, the energy, potentially the live data, forecast, and the historic archives. If we drill down, we see the tank. The tank will have specific parameters that it has to keep at the moment. We will be able to track that, and we also want to make the solution feasible for different fishes, and we want to make it customizable. Here we have the case of salmon and all the data about the salmon.
So, we have looked at the world's largest producer of salmon in this case, and seeing how they might implement the solution. So, Moby here is planning to improve their production with 4.2 thousand tons of salmon. They have an idea to do it offshore, agriculture offshore, so cages in the sea. We suggest that they do it on land, implementing these solutions. This will increase the investment by 15 million euros, though it will decrease the payback period with 3 months, increase the internal rate of return by half a percentage point, which gives us an NPV of roughly 10 million euros as an increase from the offshore to the improved inland. If we look at the European market, Moby is one of the largest, producing 273,000 tons of fish. The 19 next largest competitors produce between 15,000 tons and 150 tons. So there's a huge potential market for different producers.
Now, for the answer, why did the fish come to us for the water? Actually, we hate to disappoint you now, we lied to you, it was not a joke. It's actually something much more serious. The fish came for us for water because we as a human species, we exploited so much the ocean, but now we have a solution and it's emission free. Thank you.